This is section 2.4, and we're going to deal with modeling with functions. That means you're probably going to see some word problems, and you've got to pull out the data and come up with whatever it's asking you to do. So a few examples here on this page. To model a quantity that's changing at a constant rate, f of x equals mx plus b, the following formula can be used. F of x equals constant rate of change, x, plus the initial amount. So you've got your rate here, which is your slope, and your initial amount here. So let's read this and see how that'll translate. So A part says, in 2011, the average cost of attending a public college was $8,200, and it is projected to increase on average by $600 per year. So they want you to write a formula for a linear linear function that models that. So $8,200 is the initial cost in 2011. 600 is the rate of change per year. So cost function, c of x, could be 600x plus 8,200, where x is the years after 2011. So that way you could estimate future cost based on that. B part, a car's speed is 50 miles per hour, and it begins to slow down at a constant rate of 10 miles per hour each second. So down here we've got 50 is the current speed, 10 miles an hour is the slowing rate, and because it's slowing, it'll be a negative 10x plus 50. So that would be a line that would be going down like that. The last one, a 100-gallon tank initially full of water is being drained at a rate of 5 gallons per minute. Write a formula for a linear function. So 100 is the initial amount. 5 gallons per minute is the rate of draining, and that's a decrease. It's decreasing, so it's negative slope. So we have negative 5x plus 100. How much water's in the tank? So we have that here on A part. B, how much water's in the tank after 4 minutes? Well, the time is x, so negative 5 times 4 plus 100. That's going to be 80. Okay, so this is what that looks like. C, identify the x and y intercepts and interpret each. And so the tank initially holds 100, and then down here the tank is empty after 20 minutes because you've taken out every minute it was decreasing by 5 gallons. Now the domain, let's think about that. What are the restrictions on x? Well, the tank can only hold 100 gallons, so we can't go over 100 when we're subtracting. So x has to fall between 0 and 20, because 5 and 20 would be 100. 5 times 20 would be 100. So there's your domain. X has to fall between 0 and 20. The other thing on this page is also in your handouts. There's a page in the yellow packet that's about special functions. One of them is the piecewise function. This is a function that is literally, you have a brace here made up of more than one function, and it has parameters. So it says there's a piece of it that is x minus 1 for every x greater than 2. And there's a piece that's negative 2x for every part where x is less than or equal to 2. So we're going to use our calculator on those, and you put them in, you put these parts in parentheses, you put the parameters in parentheses. So this would be x minus 1, and then you'd have x greater than 2 here. You'd have negative 2x, and you'd have x less than or equal to 2. Now, where do we find these inequality symbols? Second and math on the calculator. Let me pull the calculator up here. So if we do second and the math, we have all of the inequality symbols. So they would be right there. All right? So the other thing you want to make sure is that you put it in dot mode. Dot mode. It tells you that right here. And when you're in your calculator, depending on which one you have, So if we go back to y equals, let me go up. And in the older ones, you just go over here and you hit enter, and it will take you through the different kinds of lines that you can use. So if I hit enter here for the newer ones, I've got to come down to the line, and then I can go thicker. I can do an inequality there. I'm looking for 3 dots. There we go, 3 dots. That'll be a dotted line. So that's how you can get there for these. If it's the older calculator, you're just here and you'll hit enter and you won't have this little thing pop up. You'll still be looking for the 3 dots. The other one, oh, and here's a picture of one that looks like that. So you get this piece and you get this piece. Now the only thing the calculator won't do is draw either an open circle or a closed circle. Here we know this piece greater than 2, that at 2 it's an open circle. Here on this piece it's less than or equal, so that one's got a closed circle. All right. The other one is the greatest integer function, and it's like double brackets. And so it's the greatest integer under x. So if you have the greatest integer value of 3.8, that'd be 3. Of 7.5, that'd be 7. So this is a step function. It draws little steps like this. And to get that, the easiest way to put that in your calculator is math over to number, and it's int. Let me show you that on the calculator. So let's go just to plain there. We'll get back over here. And if we go to math, over to number, and then int is number 5. And then if it's just plain x, we can put an x and close that parentheses, and then we can graph. Oh, I didn't do the, here, let me do zoom 6, and there we go. Sometimes you'll have to put it in dot mode. This one didn't have to. But there you go. You've got the steps. So we're going to do some things with those, but that should be the notes. Let's go look at our problems. All right, number 1, write a symbolic representation for the function that computes the long-distance phone bill in dollars for calling T minutes at 40 cents per minute with a fixed fee of $3.95. So $3.95 is our y-intercept. That's our fixed amount. That's going to go here. And our slope, our rate is 40 cents per minute. So that would be 40, and there's a t representing the minute. So you just put the numbers in like that. Find the formula for a linear function that models this table. So we've got these points, x's and f of x. Calculate the difference between f of 1 and f of 0. So we have 0 minus a negative 6 is 6. So that, well, we were actually going this way. Excuse me. So you've got, these are increasing in the y's by 6. So you add 6 to each one, you get the next one. So that is your rate. And this is 6x minus 6. The y-intercept is negative 6 because that occurred when x was 0. All right, number 3. Choose the graph that models the cost of buying X sodas at a price of $1.27 each. Well, that's going to be a positive slope, and if no sodas are bought, the price is 0. So you're looking for the line with a positive slope and that starts with the origin. This is a negative slope. That's a horizontal 0 slope. Here's a positive slope, but it doesn't start at the origin. Here is a positive slope that does start at the origin. Number 4, write a formula for a linear function that models this, where x is the number of years after 2007. So in 2007, the average adult ate 52 pounds of chicken. that amount will increase by 0.6 pounds per year until 2012. So initial is what we start with in 2007, and this is our rate. You want to pull those numbers out or note them in your head. All right, so the linear function could be 0.6x plus 52. Remember, it's constant rate times x plus the initial amount. All right, we're doing the same thing here. A stone is dropped from a water tower and its velocity increases at a rate of 32 feet per second squared. The stone hits the ground with a velocity of 224. So the initial velocity is 0. And so we don't have a plus b here. We don't have an initial amount other than 0. And the rate is 32 times the time. So what does the input variable represent? It's time. State the domain. Well, the stone is dropped at t equals 0. It hits the ground when v of t, the velocity, is 224 feet per second. So the value of t for which that's true is 224 divided by 32, so it's 7. So that means the domain has to fall between 0 and 7. Number 6, same idea. In 1900, the average number of people per square mile in a country was 21.7. That's our initial. And it increased on average by 7 people every 10 years till 2011. Write the formula. So that's 7 people every 10 years is 7 out of 10. So that's going to be 0.7x plus 21.7, which was our initial. All right. The domain of the function. Okay, the domain. So we have to think, what does x represent? X represents the years after 1900. So x could be 0, because that means that's what it would be at 1900. But how many years is it from 2011 to 1900? If you subtract that, you get 111. So x needs to fall between 0 and 111. Okay? All right. And then, I think, is that all we were asked to find? I think that was it on that one. All right, number 7. In 2007, there were 70 million people worldwide who had been infected with a particular disease. At that time, the infection rate was 5.4 million per year. Write a formula that models the number of people in millions who were affected in X years after 2007. So 2007, and then it wants to estimate 2019. So for 2007, that would be 5.4x plus 70, because we were in millions. Then we figure out from 2019, 2007, that's 12 years. So we're going to use this function and plug in 12 for x. When we do that here, we get 134.8, but we want to put it in millions, so it's 134,800,000, and you'll put that in your final answer. Number 8, an individual driving a car along a straight road. The graph to the right shows the driver's distance from home after X hours. So here's the hours, here's the distance. Use the graph to evaluate f of 0.5 and f of 3. So at f of 0.5, I said that's right about here, and when you go up and hit our line, we're at 10. So that's about 10. F of 3, right here, we're at 30. Choose the correct interpretation of the slope of the line segments below. So the slope gives the car's velocity. That's the velocity. Describe the car's motion by filling in the blanks. From 0 to 2, And here we just started. So 0 to 2, we're moving away from home. From 2 to 3, we're coming back towards home. For 3 to 4, we're not moving. That's static. 4 to 5, we're moving towards home. So if this is the beginning, then we were moving away, we're coming back, we're stationary, and then we're coming back home. So identify where f is increasing. So it's increasing. Remember, we talk about it in terms of x. So from 0 to 2, we're increasing. Where is it decreasing? From 2 to 3 and from 4 to 5. Where is it constant? That'd be 3 to 4. And here's your options that you could, there'll probably be a pull-down menu for those. All right, complete the following. Here's our piecewise function. Determine the domain. When you want to do that with a piecewise, you find the first value that you're talked about in your parameter and your last one. So x has to fall between -5 and 5. Evaluate f of -2. Well, you find where does -2 fall in the parameters. Is it between -5 and -1? Is it between -1 and 1? Is it between 1 and 5? Well, it falls here. If that's the case, then we plug in to this one. So 4x, 4 times -2 is -8. Evaluate f of 0. Well, 0 falls here. Well, everything in that group, the value of y is going to be 1. So we get that. Now, evaluate f of 5. Well, 5 falls here. So 2 minus 5 is -3. Then we choose the correct graph. And I have put what you would put in your calculator. I've got a screen here showing if you go to your y equals and you put the parameters in like this. Now note that this one has compound inequalities. And you take from here, whoops, let me see, can't do that. You take this piece from -5 less than or equal to x, that's in parentheses, and then x less than or -1, that's in parentheses. So let's go back down and look at the chart that I have. So here we go. So we got 4x, we got -5 less than or equal to x, and we got x less than or equal to -1. You do the same thing with all 3 lines, and when you hit graph, you get this. There's our 3 pieces. And we should be able to pick this right here, okay? All right, number 10, let's see. This is another one that is just graphing, and I've put it in over here with the compound inequalities. And if you need to do a fraction, you can do it a couple of ways. Let me bring the calculator up just to show you something. So if I wanted to put in 7/4 as a fraction, if you do alpha and y equals, the first one says put it in fractions. So you just hit enter, and it's going to give you a fraction icon right there. And then you could hit 7, use your right arrow, and put 4. So that's just a quick trick. Alpha and y equals gives you that fraction possibility. But anyway, you do all of that, zoom 6 unless it tells you a different window, and this is the correct graph. Now what you do notice is B and D look alike. Where's the first place that it looks different? Right here. That's an open circle, that's a closed circle. So you have to look back at your parameters. When x is -2, we've closed that circle at -2 because it's less than or equal. So that is closed there. and then this one, -2 is less than x, so this one has an open circle. So you'll just have to look and double check with your parameters and how they go in order. All right, 11 is the step function. And so you're going to put that one in, y equals, and you'll do the int and put -3x plus 3 in there. And it tells you the window to use here. So you can, here, I've got that. That's how to put it in. And here's the window. -5 is the x min, 1.5 is the x max, and 0.3 is the x scale. Then -8, 8, 1. So if you'll put those in for the window, you will get an exact, you'll get a really good match. So we do that. Then when we do f of -2.4, you're plugging that in. Let me see, let me get that, I'm going to get that in the calculator. Okay, so I got it in mine. Here is what's on the window. And so to evaluate these, you can do second calc, which is above trace, choose value, because it's going to ask for an x value. We're going to put in -2.4. I wanted you to see that because we changed the window. And so if we're going to be evaluating, what we want to do is get back out of that and do a zoom 6. That's a bigger window, and now we should be able to do that. Let's do second calc, -2.4. Oops, clear that. -2.4, and enter. And we get 10. We can do it again for 1.4. Second calc value 1.4. And there you go. You get the -2. So we did the window like it suggested so that we could get a perfect match and find our window. Then I would say to do the evaluations, go to zoom 6, and it'll allow you to do that better. And that should get you going on 2.4.